We had just covered a little bit of a difference between two terms that sound a lot alike, error detection and error correction. And again, just a quick reminder, detecting something doesn't mean you're correcting it. Something you want to watch on your exam. The reason I bring this up is that the data link layer performs error detection via a little something called the frame check sequence, FCS. Now, the actual operation, I mean the real details of this operation, it does go beyond the scope of the CCENT and the CCNA exams, but I want you to know the basic operation of the FCS. The first one is where the sender of the frame runs a mathematical formula and algorithm against the contents of the frame. Secondly, the sender will place the result of that value into the FCS field of the frame and then sends it. There's a little frame check sequence reserve spot. Sender puts that value right in there, sends the frame. Now, the receiver of the frame is going to run the exact same algorithm against the content of the frame. And if the resulting value matches that in the FCS field, everything is beautiful, the frame is fine, life goes on. If that resulting value does not match, though, that frame is considered corrupt and is then discarded. So here you'll notice I mentioned error detection but not error correction. Why don't we have any error recovery? Well, it's the recipient of the frame that actually detects the error, not the sender, and the recipient can't do the actual error recovery. The recipient cannot retransmit the frame to itself. So let's talk about that physical layer here for a few minutes. All the work we do at the upper layers is all about sending the data across the physical layer in the form of ones and zeros. And I say that all the time when it just feels like everything is getting a little complicated, whether it's in my studies or I'm creating a course, anything, I just say, hey, you know what? It's all ones and zeros. You know, anytime you see an ad on TV for a tech course or a tech school, they always have those spooky looking zeros and ones in the background, you know, those binary strings. Well, that's what it's all about, turning everything we send across into ones and zeros. We're turning it into electrical signals. And electrical signals, of course, have two options, right? Off, on. That's it, ones and zeros. Anything to do with a physical cable or the standards in use, you know, the pins, the connectors, the actual electric current is running at the physical layer. Now, later we are going to talk about different types of cables we use in this business. We're going to do most of that in our Ethernet section. But right now, I want to talk about this process we've got to go through because our end users are typing words and sending photos and watching videos and, you know, doing whatever. It sounds like we have a lot of work to do if we're going to turn all of that into ones and zeros. And it's almost like we need an organized plan of how to do so. And by golly, we happen to have one of those. It's called the data chopping process. It's really not called that. It's called the overall data transmission process. I like data chopping better, but I wouldn't use that on a job interview. But it's a good reminder for network newcomers as to what we're actually doing here. Because when the end user sends that data, inputs that data, the data goes through all 7 layers of the OSI model, but it doesn't keep the same form because it can't, because then the physical layer would be getting huge chunks of data and say, you know, what do you want from my life? You know, I do ones and zeros. That's all I do. So instead of that, the transport layer begins the process of taking the data and segmenting it into smaller units. And each layer below the transport layer continues that process. It's going to break it up into units even smaller until the data has been transformed into our stream of ones and zeros, and we can send that across the wire. Now, I can practically guarantee that these data unit terms and their associated layers are going to show up in several different ways on your exams. I know you're paying special attention to everything I say, but make sure to do it especially for this part. Now, at the application and presentation and session layers, data is simply referred to as data. And while there are important operations going on at these layers, as we've discussed, the breakdown of the data has not actually started yet. That process begins at the transport layer where the data is placed into segments. Then at the network layer, the data is placed into packets. Then the data takes the form of frames at the data link layer, and then finally at the physical layer, data takes the form of bits, and those bits are all ones and zeros. Now, for just a little exam tip here, A couple things you should be ready for. Of course, straightforward questions about this. At the network layer, are we working with segments, packets, or frames, that kind of thing. But if they mention segments or packets or frames or bits in a question, then if I were writing the questions, just saying, I would be expecting you to know which layer we're talking about. So if I asked you, for example, what addresses do we use at the layer where data takes the form of frames, that's kind of a two-in-one question, because you would need to know, first off, it's a data link layer, and secondly, then the answer to the direct question they're asking, which is, what kind of addresses do we use at this layer? And we know that's a MAC address. That's the kind of thing you want to look out for in the exam. Nothing tricky, but they do have what I call two-in-one questions, where you have to know something to even be able to approach the question. So let's talk about the overhead too. A little something extra here with the OSI model. There's a little extra overhead involved because each layer is going to add its own header that is going to be removed by the same layer on the other end of the session. Now these headers are layer specific. The transport layer doesn't care about the contents of any header except the one placed there by the transport layer on the other end of the session. Now, as you and I already know, just after 45 minutes together, there are almost always exceptions in networking. It always seems like I'm saying this is the rule except for, and I'm going to introduce you to one of these exceptions right now. Each of the top 6 layers is going to put a header on the data except for the data link layer, which will add both a header and a trailer. And you can see when we're doing here, data heads down the OSI model, and layers 7 through 2 add a header that is specific to that layer. You can see that they're numbered, and layer 2 adds a header and a trailer. Now, this combination of data and a layer-specific header, it's referred to as a protocol data unit, a PDU, and there's a PDU for each layer shown above, and when you hear them discussed, they're usually referred to by the layer, an L7 PDU, L6 PDU, and so forth. Now, once that data is successfully transmitted, the data flows back up the model. And as you'd expect, each layer removes the header added by its counterpart on the other end of the session. And this is what we call same layer interaction, because as the data flows back up the OSI model, layers 2 through 7 remove the header or header and trailer in the way of layer 2. It removes the header placed there by its counterpart. So say when the data starts going back up, gets to the network layer couldn't care less about the L4, L5, L6, or L7 headers. It's just going to take the L3 header. Now, again, there's a lot of information in this section that may be new to you. So it would be easy to overlook a term I just mentioned, same layer interaction, that I threw in there in that last section. And I want to review that term with you and compare it to adjacent layer interaction, because it kind of sounds the same, same layer interaction, adjacent layer interaction. They sound kind of like the same thing, but they are not. Let's take a look at the difference. Same layer interaction refers to an OSI layer on one end of the session, removing the header placed on it by the same layer at the other end of the session. So when the network layer on the sending device puts a header on that data, and the receiving device takes that layer 3 header off, that's what we refer to as same layer interaction. Now, adjacent layer interaction refers to the interaction between layers of the OSI model on the same host. For example, since we know 1 through 7 and what the order of the layers are, the application layer can have adjacent layer interaction with the presentation layer. The presentation layer can have adjacent layer interaction with both the application and session layers, because those are the layers directly above and below it, and so forth. Okay, so be very clear on the differences between adjacent layer interaction and same layer interaction. Now, we have spent a lot of time here with the OSI model, and we're certainly not done with it, but there's another networking model that I'm going to introduce you to on the next video. It's called the TCP/IP networking model, and there have been some changes to it. So if you have studied networking or studied for the CCNA previously, don't skip the next video saying, okay, I already know that TCP/IP networking model. There's been a little bit of a change, so we will discuss that on the next video. See you there.